Hello, geometry students. Mr. Zacek back and better than ever. We are in lesson 9 and we are looking at a composition of isometries, or another word for isometries is a composition of rigid motions. And remember, with those two things that they, number one, preserve distance, and number two, preserve angle measure. So a composition of transformations is a combination of two or more transformations performed one after another. And they can be expressed in two ways. All right, so the first one is we have this translation right to 0 following a reflection in the line y equals x, and this is our pre-image and this is our image. Now this little O here means following. Okay, so following. And so the order is really important, and this is the critical piece, is if Andy followed Matt, then who went through first, or who went to the door first? Matt went to the door first. So do this first and do this second. And people, you know, a lot of times their kind of initial reaction to this is, well, that's dumb. Why don't they just say do this first and then do that second? And I like to remind you that math is a language and the notation is a language. So just like in the English language, we could say, you know, Matt went through the door and then John went through the door. We could also say John followed Matt through the door. And both of those things mean the same thing. They're just different ways of saying that. And it's the same way in this situation. So the other way we have it is with our kind of function notation. And in this case, we're still going to do this one first. I probably should use a different color. And then we're going to do this one second. And again, this is always our pre-image is the point that we have here. And this is the image. This is kind of along the lines of function notation. Okay, so now we have a couple of special cases. We're going to practice these here in just a moment, but we have a couple special cases, and the composition of reflections across two, here's the key, parallel lines is a translation. So again, let's work on this. What's this little O mean? Following. So a reflection in the line y equals m following means this is first and this is second of triangle ABC is A double prime, B double prime, C double prime. So let's look at what happens here. So A, when we reflect it over this line, goes to A prime. Remember, this line of reflection is the perpendicular bisector of the segment connecting C and C prime. Okay, and then what do we have again? We've got another line of reflection. That's another perpendicular bisector. And look at what this case is highlighting here is that if we look at ABC, when we reflect over two parallel lines, isn't that just the same as one slide or one translation? And here's the key little idea that we also need to remember is it's twice the distance between the lines. So however far between line L and M, whatever that distance is, the whole translation is twice the distance between the parallel lines. Okay, so that's one special case that we have of this. All right, another special case is the composition of reflections across two, here's the keyword, intersecting lines is a rotation. So again, we have a reflection in the line M following a reflection in the line L, and this is our first one, and this is our second one. And so let's look here. We've got A, B, C, and so we reflect to A prime, B prime, C prime, and then we reflect it again to A double prime, B double prime, C double prime, and the center of rotation. So really, what is that the same thing as? That's the same thing as one big rotation from here all the way over to here. And how do we know what that rotation is? It's twice the acute angle measure. So the acute angle, if we look at these two here, this one would be the acute angle. It's the one that's less than 90 degrees from the intersecting lines. Okay, so two special cases that we have of them. And here's our third one. This one's called a glide reflection. A glide reflection is a composition of a, let's look at this, translation, capital T, and a reflection, lowercase r, such that the translation must be parallel to the line of reflection. The translation must be parallel, or another way we could say this is the vector of translation must be parallel to the line of reflection. When you have a glide reflection, the order, it doesn't matter. You can either translate it first. So this here in this example with the paw prints, this is the line of reflection. And this here, this line is the vector of translation. And again, what makes this a glide reflection is the fact that those two lines are parallel to each other. So we slide it up and we reflect it over. Okay, and that one's called a glide reflection. So those are three special cases of different types of compositions of rigid motions or compositions of isometries. All right, now we're going to do some examples to get cranking here. All right, so graph triangle PNB with the vertices and its image after the transformation. Okay, so P is 2, 2, N is 3, -1, and B is -1, -2. So it said graph this, so it's 2, 2 is P, 3, -1 is N, and B is -1, -2. So that would be point B, and we would take a straight edge and we would connect those points, and there's our starting thing. Okay, now again, the challenge for us is to figure out what do we need to do first, and we want to identify that. This is what we're going to do first, this is what we're going to do second. So I don't want to write too big because I have to fit two of these here. So we'll call this P prime, N prime, B prime. And what are we doing? A translation of 2, 0. That means we're going to add 2 to the X value and 0 to the Y value. So that would be 4, 2, 5, -1, and 1, -2. And so I'm just going to graph this over here. I'll put it in a different color. I'll put it in green. All right, so 4, 2. Really, what are we doing? Everything is just sliding to the right 2. So that's P prime. This is N prime. And this is B prime. And we have here that triangle. Okay, now the next transformation that we're going to do is we're going to do a translation, a reflection across the line y equals 3. So I'm going to call this P double prime, N double prime, B double prime. Okay, a reflection in the line y equals 3. So what I like to do with those reflections in the line, I'm going to make it a dashed line. And I remember that y equals 3 is a horizontal line. X equals vertical. Y equals horizontal. So y equals 3 is our horizontal line. And I have to be careful because I want to go from our from P prime. So I count P prime. How far away is P prime from y equals 3? It's 1 away, so I'm going to go 1 up here, and that is going to be P double prime. N is 1, 2, 3, 4, so I'm going to go up 1, 2, 3, 4. This would be N double prime, and B is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that's B double prime. And this is our, we'll connect these, whoops, let me get a solid line again. We'll connect these with a straight edge here. And now I need to state what those coordinates are. One little thing just to note here, sometimes people, they forget where the origin is. When they draw these lines of reflection, they almost reset and make 0, 0 a different place. So always go back to your original origin. So P double prime is 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that's 4, 4. N double prime is 5, 1, 2, 3, 4, 5, 6, 7. 5, 7. And then B double prime is 1, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 8 would be point B double prime. All right, so we graphed the initial one, we graphed its image of the transformation, we labeled it, we stated the points, we kind of got all of our bases covered, all right, and we did a composition of transformations. All right, now we have another one here, a little bit different, okay? Let's go ahead and figure out our notation again. What do we got going on? Well, we're going to do this one first, and we're going to do this one second because that little O means following. So let's start off with writing these down. So we have T is negative 5, 2, E is negative 1, 3, X is negative 2, 1. And so we've got T prime, E prime, X prime. Okay, what are we going to do first? Okay, a translation of 0, negative 5. That means we're not changing the X value in any of these. What are we doing? We're moving it down 5, which means the Y value, we're going to subtract 5. So that would be negative 3, that would be negative 2, and that would be negative 4. All right, so I'm going to go ahead and plot these. So I've got negative 5, 2, that's T, negative 1, 3, that's E, and then we've got X, which is negative 2, 1, X. All right, triangle text. So we went and we moved those down. I'll use a different color. Let's do green with this one. So we went down 5. So T became down here to negative 3. That's our T prime. Negative 1, negative 2. Here's our E prime. And X is negative 2, negative 4. Okay, there's our X prime. So this is what we've got going on there. All right, now we got to do the second one. So T double prime, E double prime, X double prime, and a reflection in the line X equals 0. So remember, X equals 0. X equals is always a vertical line, and this is the y-axis. So we're just going to flip it over however far we were from that point. So E is 1 away, E prime is, so E double prime would be over here, X is 2, so we would come over here, X double prime, T is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, T double prime. All right, there we go. We got our points. And I'm going to just state them over here. And so this becomes 5, -3. This point is 1, -2. And this is 2, -4. All right. So just when there are three things when you're doing these is that you always want to state the points. That's what writing out the numbers form is. You want to graph them and you want to label it on the graph, meaning like T double prime is written on the graph next to it. Those are the three types of directions that you'll be given. And if they don't always ask for all of them. We're not always asked to do all of them, but when we are, it's really important that we do those. So just to kind of cover your bases, state, graph, and label. If you just get in the habit of always doing those, you'll always cover that and you won't have to worry about it. Okay, what type of composition of isometries is this? Well, here's what I want you to notice. When we translated, here was the translation, here was the line of reflection. What do we notice about the line of reflection and the vector of translation? They're parallel to each other. So this is a glide reflection. And the reason is why? Because the vector of translation is parallel to the line of reflection. Okay, parallel to the line of reflection. All right, so again, that one has a specific name. It's called a glide reflection. Okay. 3. What is, these ones are a little bit harder when they give you one and it's not on the coordinate plane. Okay, let's review though. What do we know? Okay, so we have lowercase r, that's a reflection. We're going to do this one first and this one second. Okay, so a reflection in the line y or the line M following a reflection in the line L of the letter J. Okay, so what is that? Well, let's see if we can kind of draw this. So, you know, if we were to, again, the line of reflection is the perpendicular bisector. So it would look something like this, right? But then we'd have to carry that out again. And it would have to be equidistant from that line. And then it would be something like that. Okay, somehow the J got bigger as it went along. Let's see if I can try to make that a little more like what it actually looks like. Okay, so the composition of a reflection off two parallel lines is equivalent to what single transformation? That would be a translation. Okay, so again, what could we do? We could really just slide this all the way across. What is the distance of the resulting translation? All right, it would be twice the distance between lines, line L and line M. So however far apart line L and line M are, that would be the distance of that vector of translation. Okay, so another one of our special cases. And here's our third special case. What is a reflection of here? Now, what I want you to notice is that these are intersecting lines. Okay, so when we're reflecting here, let's see how well I can draw this. All right, again, we're going to reflect what? This is first, reflection A is first, reflection line B is second. So this point, the line of reflection is the perpendicular bisector of the segment. So this is going to come out and be like here, and it's going to kind of something like that. And then it's going to reflect over this line here. Whoops, not like that. So line B I'm not very good at drawing these. And the composition is equivalent to what? And it would be a rotation. So when you have two of those, and so if we were, it was to be a rotation about point C. All right. Again, I've drawn these not well. A rotation about C. And what are the center and the angle of rotation for the resulting? So a rotation centered at C, and it would be 90 degrees. And the reason it would be 90 degrees is because this angle is 45, and it's always twice the angle. So you can kind of clearly see that my drawing is horrible, but we've got the right components that we have there for that. And I would imagine that many of you could draw that much better than I am. Okay, so we want to describe now the composition of isometries that maps the black figure to the gray figure. Okay, so when it says a composition, we're thinking, okay, there has to be more than one. So this is where we start here. Okay, well, what I would notice is, what if we reflected it over? So this point would come over here, 1, 2, 3, 1, 2, 3. If we reflected it, that would kind of get it in the same, so we're 1, 2, 3, 4, 1, 2, here and here. Now we're facing the right way. So we would reflect it, and then what would we have to do at that point? Well, we'd need to move it up 2 and over 1. Up 2 and over 1. That would get us in the right place. So we could say a translation of 2, 1 following a reflection in the line x equals 0 of the black figure would equal the gray figure. Okay, or the other way we could say that is a translation of 2, 1, and then we could say following, so it's, we just write it differently, and that other notation of the black figure equals the gray figure. All right, let's try another one. Describe the composition of isometries that maps the black figure to the gray figure. Okay, again, in this particular diagram, it's a little tough to see the, this is our axes here. Okay, so just to clarify that. Well, what do we have there? Boy, it's not facing the same way. Well, what if we reflected over this? What if we did a reflection over this line here first? Well, that would be, how far away are we? 2, so that would end up here, and we're 4, so that would bring this over here. That would kind of get us in the shape of it, right? If we had this, and yeah, that would give us that shape if we reflected over, this is the line x equals 0. And then what if we reflected over the line y equals 0? Well, yeah, that would flip it on flip it on down. So we could just do 2 reflections. So let's write that out. So if we did a reflection in the line y equals 0, following a reflection in the line x equals 0 of the black figure, that's our pre-image, we would equal the gray figure. Hip, hip, hooray. All right, and let's just write it the other way. Reflection in the line y equals 0, x equals 0, okay, of the black figure equals the gray figure. Other ways you could write this is, instead of saying y equals 0 or x equals 0, you could say that this is the x-axis or the y-axis. So y equals 0 is the x-axis, x equals 0 is the y-axis. All right, and if you're sitting there thinking, isn't that just a rotation through the origin, or a rotation of 180 degrees through the origin centered at the origin, you would be correct. That's also exactly what that is. All right. So identify each mapping as a translation, reflection, rotation, or glide reflection. Write the rule for each translation, reflection, rotation, or glide reflection. For glide reflections, write the rule as a composition of a translation followed by a reflection. All right, so let's look here. So we've got ABC going to EDC. ABC going to EDC. So here's ABC going to EDC. Well, we could do that as a rotation centered at C of 180 degrees. If we just spun that around, that would bring that one up there. You could also do that as 2 reflections, would be another way of doing that one. Okay, how about EDC to PQM? So let's look at those now. I'm just going to kind of erase my highlighting because the little highlighter helps me see what we have going on. So EDC, and we want to get that to be PQM. PQM. Well, what I'm thinking is that would be a translation and a reflection. That looks like a glide translation. So let me go back and see which order. Write the rule as a composition of a translation followed by a reflection. So if we wrote this as a translation, what do we have to do with E? We got to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would get us there. We don't need to go up or down, just a translation of 11, 0, following a reflection. And what line would we need to reflect it? Well, that would be the line y equals 1. That's a glide reflection, okay? Because the vector of translation is parallel to the line of reflection. All right, so again, I'm going to erase my highlights. Sometimes there's more than one way to do these things. Many times there is. So MNJ, so we got triangle MNJ, and we want to get it to triangle EDC. That seems to be a popular one here. Well, that to me just looks like a translation. Let's see, what do we got? If we're going to go over from J, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a translation of -9, 0. We're not going up or down. All right, H, triangle HIF. So triangle HIF, where is it? Where are you? Triangle HIF, there you are. To triangle HGF, that is just a reflection. And what would the line of reflection be? Say, well, it'd be this line right here, which is a horizontal line. So it'd be a reflection in the line y equals 1. And what do we got? I think we got one more. Okay, PQM, triangle PQM. So PQM down here, where are we trying to get that to? JLM, okay. Well, you know what that is? That's a reflection, but this reflection is through a vertical line. What is that vertical line? Well, where does it cross the x-axis? It crosses it at 1, 2, 3, 4. So we would say that is a reflection in the line x equals 4. Okay, lots of stuff, a little bit of a longer lesson. Some of them in this unit are longer because this is a really critical unit that we have here. It's a big point of emphasis in this course. So we're spending our time here giving you lots of examples. And so we have ourselves a composition of isometries, and you want to go back to the beginning and you want to make sure that you're getting the order straight. Okay, so when you're working on these things, make sure you look at what that order is. All right, I will see you back here soon.